Ladies and gentlemen, good afternoon. Thank you for joining us. We're a little behind time, and we wanted to show you the trailer actually of the festival, but we'll run it after the show because we don't want to waste, or we don't want to use all the time we have to basically build the arc, to build something that's very important, from talking about innovative ideas to actually seeing companies that drive them into the market, that manage to make it through the early technology readiness levels and that are just in the scale up. So what you're about to hear now is, or the stage you're experiencing is the Launchpad. My name's Peter, I'm the founder of FCA, and I'm pleased to be joined by somebody who's been supporting our work for a long time. It's Fabian Sacharowitz. He's the investment director of InnoEnergy, and he'll introduce their work in more detail later. But we are very excited that you're here. Thank you, Fabian. Welcome.
Yeah, thanks for the invitation, and thank you. Thanks to you to be part of this very amazing event.
Thank you so much. So we thought that's the next logical step, right? We've heard about technologies from storage to cement to aviation. We heard innovators already, but now we're looking at some that have made it.
I think so, because, well, we cannot wait again 30 years as has taken wind and PV to become, let's say, commercial successful. Yeah? So this needs to be faster, and this is something that we are also pretty much looking for, and these are also the endeavors of a lot of startups that we are supporting.
So thank you, Fabian. In this session, the plan is the following. Fabian will introduce the innovators, the companies, the scale-ups, and somebody who's representing the investment perspective, venture perspective. Fabian will then introduce or speak a little more about how InnoEnergy is targeting this process, supporting this process. We've had other panelists, Hortense from InnoEnergy today when we spoke about aviation. And then we'll hear from the very people who do it themselves, because they'll join us on stage, and you'll have the opportunity to ask questions. So It's over to you now, Fabian. I'd like you to give Fabian a warm welcome and a warm applause to start with, and to introduce the innovator. Thank you so much.
Yeah, thanks a lot. But, well, it's a pleasure for me to have amazing founder and managers of really, let's say, in the DACH region, important startups here that are driving meaningful, what we have here discussed broadly, energy transition. So let's welcome on stage Dr. Linus Froböse from Skeleton. This is one of the technology leaders in supercaps. He will explain and introduce this later. Let's sit down. So then Dr. Stenzel, who's from Set Ventures, one of the leading and most relevant VC investors in Europe in our let's say clean tech innovation or energy innovation arena. Dr. Frank Siebke, one of the founder of NexWafe, one of the most amazing startups or technology startups that I know in Europe. That's also always the micros is falling down. And last but not least, Kees van der Kerk, who is managing director of Volterion, a flow battery producer and president of Flow Battery Europe. And yeah. So allow me to briefly start I will rush through a presentation, not to present InnoEnergy. I think this might be somehow known, but to present an idea that we have how especially hardware innovation can be brought into the market faster than maybe usual. So next slide. We are on the next slide. Arrange. So this is, we actually have an example how energy innovation has been scaled in Europe much faster than wind and PV. So if you remember 2017, Europe looked quite bleak in battery production. In almost all the fields, Europe were no player in the world. Next slide. This has changed tremendously since 2017. Now in 2022, we have announced projects for battery cell production of hundreds of gigawatt hours in 2030 to come. So amongst these projects that has been announced, there are incumbents like LG, like Cuttle, all the let's say incumbents, the corporates, but also startups, well-known startups as Northvolt that has announced to build 150 gigawatt hours in battery capacity in 2030, but also startups that are just recently launched, like a case that I will present later on. Next slide. How could that work? So these are expressions from different persons. Hardware is always something that is considered as hard to scale, costly, takes time, uncertainty, and so on. So even from my experience as investor, I can say it's harder for hardware startups to get financing than for software ones. So next slide. So why is that? Why is it so? It has to do with well, it's difficult for innovations to, let's say, to break through existing value chains that has been, well, living the economy of scale for years or decades. And if you have, for example, I brought with us an example from a potential value chain in in food with a very low or zero footprint. So if you imagine that fertilizers would be made with hydrogen to be more or less CO2 neutral or very low CO2 neutral footprint, then there are a lot of players in the value chain that can say, hey, the fertilizer producer says, I'm not taking the risk that the farmers would not buy my fertilizers. The farmers say, hey, why would I pay more for the fertilizer if the distributors would not buy it for me? Because they say, hey, I want to have my margins, and I don't think that the consumer is buying more for his food. Although the consumers might be interested in buying CO2 neutral food. So at the end, this would not come along. And so this is why we propose, next slide please, something that is not rocket science, but what we call the value chain approach. So bringing together the entire value chain, most notably the off-takers, but also the producers from the raw materials up to the producers, to the OEMs and so on, to together work that innovation can be brought, accelerated into the market to satisfy client demands. So then we are talking about a pull that we see from the clients and not from a push from the existing value chain that pushes products to the consumers that they potentially don't want to buy anymore. This is something that already works. We saw it, and this was, let's say, for us also the starting point to think about something like this at Northvolt, for example, because Northvolt had the off-takers, notably the car industry, the car OEMs, from the beginning on in their cap table and as partners with them. So it was this amazing race was possible, and we now see it in cases where we invested in, for example, H2 Steel. That's quite well known that the car OEMs are willing to pay a 20% premium on steel because, well, this translates in roughly 200 euros more for a car. This is something that end consumers are willing to pay. So, but to make this happen, though, we need the entire value chain to work on this, that the end consumer price of the green steel is not over the 20% that the car OEMs are willing to pay. And this only works if all of the value chain would work together. Okay, next slide, please. This is, well, a schematic approach of what I've already talked. Let's skip this. Next slide. Here's an example that I already mentioned a bit. Vercor is, let's say, well, also a battery producer. It's just for me to mention how this can look like. It was funded in 2021, in early 2021, by Energy and others, Schneider Electric, Capgemini, and EDEC Group. And then it was founded as a startup, and now it flies alone. It has secured Renault Group as investor in summer 21 already, and has now 200 employees and really working on their pilot line to produce battery cells, actually. Next slide, please. I will not run to this. These are from our perspective a bit part of the building blocks that are necessary to scale hardware innovation fastly. Maybe the most important point is definitely the team for us. So you need at the end, it's all about convincing investors to put meaningful amounts of money that for an idea that would pay off in the future. And this requires some things to happen. First, an incredible good team, and then a founder, shareholders that are working with, actively working with. And if we're talking, for example, about strategic shareholders, they cannot think that they would, let's say, earn or make business with this venture. No, it's about funding a startup that flies alone and that takes the decision that are the best for the venture. Something that I also want to mention is something really important that we see is the work that the startup works together with incumbents, with corporates. We need to bring, often replicated, but we need to bring the investors' innovations together with the scaling know-how of the corporates. So corporate need to be in the boat quite as soon as possible to put their know-how in this arena. And the off-takers. Really important. If you have off-takers in the boat, then an investor would definitely be more keen to invest in the case than otherwise. Next slide, please. One thing that I want to mention that is an example for another case where we need innovation, but there's no value chain at all at place. This is a picture from a typical week from Southern California, wind and solar from 2018. And we see wind and solar not with a stable delivery of energy, even in Southern California. So what we need is a renewables energy production that is out of phase with wind and solar. And this could be ocean energy. So the ocean energy line is there calculated by buoys that by real measurements in 2018, 1 week again. Because it's really out of phase with wind, because first comes the wind, then the waves. And now, next slide, please. And our portfolio company, Core Power, is really working on making this ocean energy, let's say, in terms of costs, in terms of quality, let's say, feasible. And this is a really hard endeavor, because what I taught about value chain does not work here, because we don't have a value chain. So they have, and I don't want to go to all the steps, but they have a really sophisticated development R&D roadmap that takes over 10 years, and they are going through different steps of prototypes, but also really large-scale prototypes and an entire certification cycle to at the end convince investors that this is something that would work. So to achieve bankability. Next slide, please. Now let me allow just InnoEnergy is an organization, and we are an investor, public-private partnership, because we are a private company, but still backed by EU money that would go down. So in the future, in 2 years, we will need to fly by our own. And our approach is really, next slide, please, to use these to work in these value chains. We have the value chain started with the EBA, with the European Battery Alliance that we are driving for the EU Commission, and have set up in the EBA, working together of the entire value chain in batteries, and have replicated this for green hydrogen, and now for ESI, for photovoltaics, to bring back, let's say, a production of photovoltaic in Europe, in this photovoltaic industry. And we really believe in this value chain and try to invest in this value chains. And this is maybe something that makes us a bit special, that all, together with our ecosystem that we're building around these kind of value chains. Well, that's all, a bit rush. And now I'm asking Linus to briefly present Skeleton.
Thank you, Fabian. So thank you for your introduction, and thank you also from my side that I can be here. And yes, Beyond Batteries is the title of this presentation, which will be quite short. And on the next slide, I would like to give a little impression what skeleton technology actually is, where it comes from, and what we are doing. So at the end, it's a quite young company. So we just heard it shouldn't take 30 years to come into the profitable range. We are 11 years old, so quite young, and we are there. At the end, we are a European company. It was founded in Tallinn, in Estonia. We have also in Germany at the moment 3 locations, one in Berlin, the smallest one in Bitterfeld, this is in Sachsen-Anhalt, and one near to Dresden in Großröhrsdorf, which is our biggest location in all Germany. So, couple of facts and figures. We are at the moment roughly 300 employees. A year ago we were less than 150, so that means we have doubled the amount of our employees. Some commercial numbers, which were also shown on the slide before, so this was a bit quick. We have an order backlog of more than 160 million euros, commercial agreements 2.2 billion, and the accessible market for our product already in 2025 is more than 60 billion euros. But what are we actually doing? We are developing and producing energy storages which can be charged and discharged extremely fast. So our technology can be charged in a second and can be discharged in a second as well. And these kind of energy storages are so-called supercapacitors. That means these are no batteries, these are supercapacitors. The beauty of Skeleton is that we do not have a single technology. Our vertical integration is quite high. That means we start with the development and the production of the raw material, and this is actually our unique selling point because we have developed the so-called curved graphene. The curved graphene is a chemical ingredient of a supercap, which is at the end the unique material which allows us to store roughly 4 to 6 times more energy in our supercapacitors at the same performance rate like the competitors. But we do not stop there. We produce the material and we produce the cells. We produce the electrodes inside of the cells, we produce the cells itself, and we also produce the modules. The modules are actually that kind of system what the customer need. So here we have our technology in the modules for different applications, and at the end, when the customer needs it, we can also combine different modules into a system, what you can see on the top right side. But coming to the next slide, where can it be used for? At the end, we are at the moment in 5 business fields, although you can just see 4 here, but I will tell you what is the 5th one. It starts with the automotive business. So we are already a tier 2 supplier. We are delivering our supercaps as a tier 2 to a German OEM. And if you buy a luxury car with an active suspension control, this is powered by supercaps. Second one, the transportation and heavy equipment industry. It is used for trucks, for trams, but also for trains, for typical energy recuperation during the braking, which is then called the Kees system. We are also in the grid and renewables business. For instance, the supercaps are being used from our customers for the pitch control of wind turbines, for instance, but also to flatten the grid. The industrial application is at the end, for instance, the supercaps are used in cranes at the harbor. That means they are charged when the lift, they are charged when you decrease the load, and you can use the same energy when you then lift the load again, and this saves 30% of the energy the crane must use. And you can actually use the same application also for elevators, for personal elevators, and this saves 40% of the energy. The one what is not shown here is the medical business. So you can use the same product also for CTs, but also for MRTs to flatten the power supply inside of the equipment, and this allows the equipment itself to make better pictures. That means to increase the quality, which at the end makes it easier for the doctor to really find out what's the issue with the patient. On the next slide, and this is also the next, pretty last slide, we also have a product roadmap in front of us. So we started with our generation 1. We are in serious production with our generation 1 product, but we are close to the launch of our new product, which is called Generation 2, where we again exchange the active material inside of the cell with our custom-made and self-made curved graphene. In 2024, we will launch the so-called super battery. This is a combination of a lithium-ion battery and a supercap inside of the cell, which allows then as well to gain extremely higher energy densities with more or less the same charge and discharge properties like the supercap. And the beauty of the curved graphene is it works also quite good in solid-state batteries, but this is something for the future. Here we have started the R&D activities. And now on the really last slide, which will be very short, at the end our business is at the moment completely limited due to our production capacities. We are producing at the moment roughly 300,000 supercaps per year, and this is the absolute limit of our current plant. And we are scaling up at the moment, not just our business, but also the hardware. And for that, we are building at the moment 2 new production plants in Germany. And with these new plants, we are then able to produce 12 million supercapacitors per year, which is 40 times more than our current output, which we can at the moment produce. So this is Skeleton. Thank you again that I can be here. I'm really looking forward for the discussion. Thank you.
So Till, do you want to present your organization briefly?
Yes, sure. Thanks, Fabian. And I don't have slides with me, so I'll give you a quick snapshot of how we view the market from Set Ventures' view. And maybe to start off with, maybe somewhat counterintuitively, part of our investment thesis at Set Ventures actually is about an age that we are entering now of abundance of energy. So it might be counterintuitive today. We have a war going on in the Ukraine. We have gas shortages. Everyone is scrambling to get resources and get energy at all. But thanks to this slow but now growing wave of solar and PV that we've now finally seen coming through, we believe we are no longer necessarily in an age of, how much can we produce at all, but what do we do with all that energy that will be produced? And so our investment fund, Set Ventures, is a venture fund focused on early stage startups in the sort of what we call in the startup lingo Series A stage. So a company that has found a product market fit, has some first customers, is growing from that base. And we want to grow with them to really go deeper and further in the market, and that's sort of where we typically invest. And so what we are looking in companies is basically those that come with new technology and new business models to orchestrate, to balance, to manage all that energy that we will have in an intelligent way to make the overall carbon-free energy system work. That is the vision of how we see the future energy system, and that is where we are looking for companies that can support that with innovative new technology, but we think equally important with new business models and ideas. And I think to Fabian's point earlier about this well-known valley of death for technology, especially in the hardware sector, where you've proven it can work at a small scale, but now you really need money to bring it to this commercial viable scale where it can be financed from regular financial institutions. This is, I think, an important challenge for the entire industry, not just for the venture industry, but the financial industry as well, because it's a financing challenge at the end. It's about finding innovative ways of channeling money. And I think the example you gave, for example, here of startups that very early on bring incumbents or corporates on board for strategic projects that then have immediately the sort of credible backing, credible finance behind them, like Northvolt, like other such companies. That is one way of solving this, but clearly we need to do more, especially when we talk about technologies that are built on a project-by-project basis. And I think this is a big challenge that we are facing. And if we find innovative ways on that end as well, I think then also this hardware challenge can easily be solved. So I'm looking forward to the discussion with all of you.
Thank you, Till. Frank, do you want to present NexWafe?
Yes.
What you funded a couple of years ago.
Yeah, 7 years ago. So please, could you please give me my slides? Okay, NexWafe has been founded to produce truly green solar wafers for the photovoltaic industries. Next slide, please. So as Fabian said in the beginning of the session, so it took about 2 decades for the solar industry to grow to 200 gigawatt capacity annually. And the reason why they were able to do it was the ability of the industry to reduce the cost significantly. by economies of scale and by continuous improvements in production. But these measures are exhausted today. And a few years ago, 2-3 years ago, the main players in the industry decided that the way ahead is improving efficiency of solar cells and solar modules and reducing material costs. And that's where we come in. So the silicon wafer, the boring piece of silicon, is the single most expensive component of a solar module. 40% of the cost of a PV module are caused by the wafer. Next slide, please. And the reason for the high cost is the extremely long process chain in production. So you start with metallurgical silicon, then you create chlorosilane, which you can make very pure. You use the chlorosilane in a high temperature step to produce polysilicon. You crush the polysilicon, you melt it, you pull an ingot out of it, then you cut off top and tails, throw them away. You cut off the side walls and remelt them, and then you have a brick which you put on a wire saw and slice it into pieces, and you end up with a wafer, having consumed a lot of energy and wasted 40% of the material. So what we do is we use our high throughput deposition to grow wafers directly from chlorosilanes. Next slide, please. This is a picture which shows a little bit more detailed what we do. We take a conventional wafer, then by an electrochemical etching process, we create a release layer, a kind of porous sponge, 1 micron thin or a little bit thicker. Then in a annealing step, while heating up the wafer for deposition, the sponge transforms in a kind of Gothic cathedral. So you have a closed monocrystalline roof sitting on very thin pillars. And then we grow the wafer on the roof, the next wafer, and we can mechanically detach the grown wafers by breaking the thin pillars. We sell the grown wafer and reuse the seed wafer. And by doing so, we can reduce silicon waste by more than 90% and energy consumption and CO2 emission by 70%. And I think that's important because there are calculations which show that if you want to do the energy transition using solar, then just creating the solar modules required would consume 10% of the CO2 budget we have if we want to stop the temperature increase at 1.2%, at 1.2 degree centigrade. So it's significant. And this means solar has to become greener. And our technology can significantly contribute to this process. Now, where are we today? Today, we are just assembling the second generation of our prototype line in Freiburg and taking it into operation to prove that the technology is ready for mass production. In the next step, we are already planning building a pilot line with a capacity of up to 500 megawatt in Bitterfeld. There we have acquired and secured a chemical plant from a former polysilicon production, which is chemically almost the same, at least for me as a physicist. Yeah. So a chemist might have a different opinion, but yeah, you take chlorosilane, hydrogen, and you get silicon out of it. That's what both of us do. Yeah? And this is located in Bitterfeld, close to a chlorosilane producer, Evonik. So we can get the raw materials through a pipeline. We can send back the byproducts, such as HCl gas, through a pipeline and have a circular economy, which helps to save cost and be environmentally friendly. And so there we want to build the first pilot line with a capacity of up to 500 megawatt. Next slide, please. And then the chemical plant in Bitterfeld allows us to scale up to at least 3 gigawatt without investing in a new chemical plant. And that's the plan of record. It's a little bit small, still a little bit small, so the optimum size would be 15 gigawatt for such a factory. And such a 15 gigawatt factory would save more CO2 than all the cars produced by Tesla within 1 year. So it has a significant impact on carbon savings. But to do that, we realized that a team of 40 people in Freiburg is too small to build a multi-gigawatt factory, and we don't have the balance sheet to get the funding we need. So we started teaming up with strategic partners. So last year, we secured our first strategic partnership with Reliance in India, and we are now working on other partnerships in regions such as the Americas and Europe. And I think that's where I stop.
Yeah, thank you, Frank. Then Kees, would you talk
Fabian?
about Volterion?
Yeah, Volterion. First of all, you see on the right Flow Batteries Europe. This is an initiative we started about a year ago because flow batteries are quite unknown. And that's my first question to you as an audience. Who knows something about flow batteries? Yeah, well, I can hardly see any hands due to the light, but I think it's about a 5. So I have 2 slides, I think, on flow batteries, just to give a kind of explanation on what it is. If I can have the next one. Well, first of all, sorry, I forgot this one. This is the market. It's going to expand and grow. I see Julia laughing. I have 17 gigawatts in Germany. Can you just press, then it moves on? You can't even read it. There it is, 13 gigawatts. England, the German, you can't read it. It's about 17 gigawatts in 2040. I saw 19 this morning, so it's more or less the same. But one thing you always see with these curves, they get steeper and steeper. So we need energy storage, and the solutions are, let's say, the new machines of this time. We need them. We can't live without them. Next one, please. A short one on Volterion. We started in 2015, so we're 7 years on the market now. We have been bought by a German exhaust system group. You can imagine why, because there's not a lot of future there. Although they still do 3 billion turnover this year and growing somehow, very clever. The good thing is they have money and they funded us, and before they started to participate, we spent, let's say, 50 to 75% of the time, management time, on funding, and that's over now. That's the best news of them coming in. And that's probably the answer to one of your first questions, Fabian. We have 2 products. One is stacks and one are complete batteries. I just want to show now in the next slide how a battery works. Basically, it's completely different from lithium or capacitors or whatever. We store energy in a liquid. So we have 2 tanks, the orange part here, and this liquid is pumped through a stack. And that's our core business, making these stacks. We have IP there. I'll show you a picture later on. And the stack is the power part of the battery, and the liquid, the amount of liquid, defines how much capacity the battery has. So if you please press again, then if you want long duration, and again, you see if you just enlarge the tanks, you double your capacity. So it's a quite simple way of scaling. And you can scale capacity independently from your power. If we move on, similarly, if you want to scale power, you just put in more stacks in your battery and you have more power. So that's one of the nice things of this battery. You can adapt the battery to the needs of your customer. Let's move on. This is an example of a flow battery using the Volterion stack. This is the stack you see here. We have IP because we weld our stacks. The conventional way of making stacks is with these metals and with seals between all the cells, and these tended to leak. The Fraunhofer Institute started the program about 20 years ago, and that ended up in Volterion coming to the market with IP to make welded stacks which don't leak anymore, and is also much easier to produce. Next one, please. This is a product we have. We have this stack, which is the heart of the battery, but we also make complete systems. These modules are, for instance, working at RWE in Essen. So we have our first, let's say, more corporate kind of customers, although we are still, I heard the word this morning, a boutique and nothing else. We're still very, very, very small. Next one, please. This is our next step. We're moving into a container, which is, still nothing, but still, well, it's 0.5 megawatt. So it's starting, but this is something we are going to produce this year for the first time. So that's where we are. Next one, please. I want to just show you an example for those who don't know, what can you do with these kind of flow batteries? This is a sewage company in the southern part of Germany where we want to put one of these containers. Please press. Here you see the power curve with these peaks, and you can bring down these peaks if you take the energy and the power from the battery, which saves cost on your energy bill, and you pay for the highest peak. So if you bring down peaks, you make more money. So they are going to put in one of our containers and bringing down the peaks. And one more press, please. This is the reason why. If you would bring down these peaks, and there are, let's say, 5, 6, 7 a day, if you would do it with a lithium battery, you have a limited amount of cycles you can do that. It's like your iPhone. After 3, 4 years, you want a new one because you have to charge all the time. And with a flow battery, you keep your capacity. So that's the line, the red line on top. Is you keep your capacity even after 10 years, after 20 years. You don't have to replace your battery. So that was a short lecture on the flow battery. I think this was my last slide. Yes, thank you very much.
So then, start to discuss. I really want to hear something, go a bit more in detail in things, how you really scale these things. So maybe Kees, starting with you, because you mentioned that that Boysen was taking over at Volterion. How was this? How was it? So is it better? Was it worse? How Volterion evolved from this time?
Well, it's the way it went. We had actually two options. One was venture capital, and the other one was Boysen. And both have their advantages and disadvantages. The advantage of Boysen was that we believed they could really help us at that time, that they really knew about how to scale, and obviously they had funding. And we also knew they had been looking for new technologies because they were in the exhaust business, dying, for 3 years already, and we would be their first party they would buy. So that was also somehow exciting. And the engineers actually really favored Boysen above the venture capital guys because they would bring money and not much more to the table. In practice, I must say life is a bit different because first of all, the Boysen group is in the market for, I don't know exactly, but at least 100 years or something with these exhaust systems doing the same thing every day. And a startup is quite the opposite. You're still developing, you're still running a risk with your product when you bring it to the market. You have to accept that risk. But if you sell an exhaust system to BMW and it doesn't work, you have a problem. So that's a kind of culture difference we had. And to be honest, it took us a year, I think, to really get to grips with that. Right now, we're getting out of the muddle, yeah. And for instance, a machine to really scale up stacks was meant to be in operation last year, and I hope it will be there by December this year. So it has pros and cons.
Would you say that this has accelerated your scaling up, or was it let's say the same?
If you have venture capital in, there's a lot of push to deliver.
Yeah.
And at the end of the day, I think we would have moved faster with venture capital than a settled company. In this case,
Interesting.
It doesn't have to be like that because I believe in your value chain approach. If the partner is really, let's say, matches you in terms of culture, in terms of approach, a bit more flexibility than this Boysen group from the southern part of Germany, which is not the most, let's say it differently. It's a quite traditional area in Germany.
Okay.
And yeah, that's the way it is.
Yeah, that's also well known that the culture between incumbent corporates and startups often is a problem.
And that's extremely important to really focus on that from the start, that you really manage that. And if there are any issues, bring them on the table and discuss and solve them.
Okay, interesting. Linus, so I would say Skeleton is maybe the most advanced venture that we have here on the stage. So already, I would say, one of the world-marked leaders in supercapacitors. What has been crucial for your scaling up, and what is in the future will be crucial to make the further steps?
Yeah, I mean, what was crucial? I mean, specifically in the beginning.
Besides the investment of InnoEnergy,
yeah, I mean, this was the game changer. Yeah, I mean, this is obvious. This I don't have to mention. This is clear. No, but I mean, when we have started, the first crucial thing: protect your business, protect your technology. I know this is so obvious, but not everyone does it actually. And what comes next? Then at the end. You must understand your business directly from the beginning. How can you do it? You must understand your customers, you must understand your customer needs, and you must understand at the end the commercial terms or the commercial properties of the applications of your customers. Because then if you understand their systems, you can also start to improve their systems, and in that case you can directly come with the technology and you can calculate directly in front of them how you can improve their systems if they use your products. I think this is one of the key findings, that you need to start with that directly from the beginning, because this opens then at the end a lot of different application fields. And I think I have shown to you that we are at the moment in 5 different business fields, but we are actually using the same product for each and every field at the moment. So the second, or it's the third step already, it's standardization. So it is actually the same cell which we use in cranes, which we use in elevators, which we use in cars. And this gives you then a high probability of economy of scale. We just heard that. And last but not least, in some cases, I think what Skeleton made really correct in that case was that we have not decided to go from a lab scale to an absolute extreme mass production scale. So we made one step in between. So I just told you that we are producing at the moment roughly 300,000 supercaps per year. It sounds already a lot clear, but compared with the real cell business, I would say it is it is somewhere in the middle between really laboratory and mass production scale. But we have done it, and out of that we have learned a lot, because at the end we are making profit with hardware. And to produce hardware, you have extreme high investments. And let's say these investments are so, you need to be careful with it. And that means also you have to learn how to produce your product in mass scale. You have to learn which kind of process technologies you would like to use. You must make failures in the beginning. Otherwise, you cannot learn how to do it correct. And then you have all the capabilities and you have all the knowledge in your own house to then make the next step to the really big mass production. And this is what we are doing at the moment. So we are scaling at the moment our production capacities from 300,000 supercaps per year to 12 million. And in that case, we discussed the corporate relationship. And in that case, you also must know your limits. I mean, we have great people on board, 300 great people are there, from R&D, production engineers, and all, and then all the other disciplines. But at the end, to build a mass production factory, you also need experience, knowledge, and in that case, we are collaborating within a big with a big company. I think everyone knows Siemens. Great company who has already built a lot of different and huge factories. And here we are actually working together with the same team, which has also scaled up the Northvolt factory. And this helps us a lot. So here, for instance, we have already developed the digital twin of our factory. We can already simulate the factory before it is online to start to optimize it, to start the different cycle times, to optimize the cycle times, the logistics, the material flows, the utilization of our workforce, and so on and so on. And I think with all of these different steps, we made it actually to be there where we are, already in a profitable range. And I think the business which is upcoming is definitely satisfying for us and for sure also for our investors.
Interesting. Did you also feel a cultural difference between Siemens and you, or is it that you have been, well, that you are already that advanced that there was not so much cultural difference anymore?
I would say there is not so much cultural difference, because at the end it all depends on the teams which you're working with, and so specifically we can feel that there is a great vibe, great speed, and this is what you need at the end. And okay. It doesn't matter where you come from in that case.
Interesting. Frank, how do you want to plan? How do you want to scale your amazing technology to the world market?
Well, I think one basic principle is that we look at our customer needs from the very beginning. So our idea is to provide a wafer which can be used by our customers without any changes to their production processes. So they can really use it as a drop-in replacement of today's wafers. And by doing so, they get additional benefits. So our wafers have, for instance, lower oxygen content, which helps to get better efficiencies. So you can gradient doping throughout the wafers, which you can't do with ingot pulling, and those higher efficiencies again. And we can do thin wafers. below 100 micron. It's not only about the material savings, yeah, but also if you look at the world record solar cells being made, yeah, they all have thicknesses of around 90 micron. And with conventional wafering, you can hardly go below 120 micron. So the world record efficiencies are out of reach in mass production with conventional wafer manufacturing. Yeah? We can easily go there and provide these products in large quantities. That's one thing. And what was it again?
Yeah, how do you want to scale this up? I know you
as
are
I think
planning
the
to
other
build
thing is to scale that, as I said before, so we will form strategic partnerships with potential customers, with people who can use our products and who have the engineering power to build large factories and to help us. So we have last year formed a strategic partnership with Reliance in India. They have decided to invest 75 billion in building a new green hydrogen economy in India, and part of that will be building the whole value chain, solar value chain, you know? Mm-hmm. And so there we have a close cooperation with the people building the solar business in India, and it's a good cooperation because they have a huge big ambition to be successful. They have speed, they have the power, and so it's the opposite than what you experience. Yeah, they are pushing us and helping us to maintain the speed.
Mm. But you nevertheless are also planning to go, let's say, an intermediate step to build up a pilot line in Bitterfeld, right?
Yes.
Like Linus taught about the production in.
Yeah, I think we still have to do the step which Skeleton already did, and I think it's important. So right now we have tools which have all the modules which are needed to build a mass production, to produce millions of wafers. Yeah? But we have to prove that we are able to do it. And a pilot line in solar means you have to at least to build 200 megawatt of production capacity. On wafers, it would be 20 million wafers a year. Yeah? So, yeah, it sounds a lot, but today the solar industry consumes 20 billion wafers a year. Oops. Even more. Yeah? So 20 million is still small, and it's something when people start thinking, yeah, if you can do that, yeah, then you can scale up. Yeah? And the problem there is that it's a significant investment is required to build a factory with a capacity of even 200 megawatt only. You'd easily talk 50 million capex. Mm.
So, but it's a step that is required to learn for the mass production, but to also convince investors for the large scale one, right?
Yeah. You will not invest 500 million if you haven't shown that.
Understood. Till, we've heard some concepts of scaling hardware innovation. Do you have, from your experience, some good best practice things, or what you want to add to these concepts?
Yeah, maybe I can add two perspectives here, because I think we heard already in some of the contributions about the corporate versus VC investment opportunities, advantages, disadvantages, and I think let's put it this way: from an independent venture fund perspective, you are typically skeptical of bringing a corporate into a startup because obviously it might limit your exit opportunities. It might create tension, complexities in daily operations and scaling, if you're not prepared for it. So I think it is really about the timing, and I think if we look at the Set Ventures portfolio, I think there's one example, a company called Sonnen, which was sold in 2020, at the beginning of 2020, to Shell in a very large transaction. But the company at that time was already at a very significant scale. And I think the story of Sonnen, in a way, is a good example for a company that grew in a niche with venture funding, without any corporate backing. And it grew to a point where it's really started to challenge the status quo to an extent that corporates, first of all, took notice, and corporates realized that this was something that was a coming market, and they wanted to engage. But that allowed Sonnen to negotiate with corporates from a position of strength. And so Shell Ventures, in an initial step, invested in Sonnen in a regular transaction for a minority stake. but it was at the point where Sonnen was already very strongly positioned in the market, where Shell couldn't, let's say, carve out any special rules for themselves. And then when they had an inside look into the company and saw how it was growing, how the market evolved, that allowed them to also then make an informed decision to buy the company at the end and help it now obviously grow further and also internationally through the Shell network. So I think for me the takeaway there was that it is also sometimes about timing and that you as a startup are in a position to negotiate from a position of strength and don't have to, let's say, give in to corporate demands too early. I mean, there will always obviously be some trade-offs. I think another example that we have in our current SetVentures portfolio is a company in the automated charging space, so really allowing electric vehicles to start charging automatically when they are parked with a small device in the car that moves out of the car, connects automatically to a small metal plate and can start charging in a conductive way, regular 22 kilowatt charging. Now, this one is still early stage, and I think it's a good example similar to what you showed us on the slide in terms of an ecosystem that you need around it. This technology will not succeed on its own. It needs the car manufacturers on the one side to use it in their regular production, but you also need the infrastructure on the other side to connect it. And so we invested in this company at a quite early stage together with two corporate-backed venture funds, so EnBW Ventures from Germany and UniEnergy, the big utility from the city of Vienna in Austria. They are co-investors here. And the reason here is that indeed there are already benefits today of having them on board for developing the infrastructure around it, so that it's not a question of a technology coming to market and then having to wait for others to catch up, but that this can happen simultaneously. So the company itself is already very advanced now with a German automotive manufacturer to really put it into a serial production on the car side. But we were really keen to bring early on infrastructure partners as well, so that they are not on day one lacking that component that will be critical for future rollout. So I think this is again, it's about timing here. It's quite early, but it brings immediate benefits here for future success of the company.
Interesting. Linus, you actually at Skeleton did not have had any client, corporate investor, right? It's so it was basically now your cooperation with Siemens is the first one that you have with large corporate, right?
It is, but let's say it is also, let's say this cooperation has at the end nothing to do with any investments or something. So yeah. It's a pure, let's say, pure two-company cooperation. Let's say we both benefit out of that. That is clear. But at the end, we are not talking about any kind of investments which are going in the one or the other direction.
But it's about scaling now.
It's about scaling. So they help us to build a new plant, to heavily increase our automatization level with our production equipment, to at the end gain out of this scale also to become here more efficient, to gain higher yields, to get these high volumes out of that equipment. Yeah.
And the 300K super capacities that you are producing right now, you managed to build up the production lines by your own?
Yes, this was purely done by our own. For sure, this was also done with blood and tears. I think this is also clear. But at the end, we are talking about, let's say, the next level of our production line is then really 100% automatized. So just as an example, we will use the same amount of operators per shift in our new plant to produce 12 million super caps like we use at the moment to produce 300,000 per year. So that shows already the level of automatization which we will install now. And this allows us as well to build these new plants in Germany. Yeah. So, and I think this is also pretty unique.
Yeah. So you are the COO of Skeleton. So what would you say is an operational model for fast scaling hardware? What is your daily business? How do you manage this scale? What you are caring about?
Yeah, at the end, how are we doing it? At the end, I think we have a quite good understanding of our product. due to the fact that we have now gained 4 years of mass, I call it pilot manufacturing experience, we have already quite a good idea how the production technologies must look like, how we specify them. We know quite good all the parameterizations and so on. And this is the, let's say, out of this knowledge, we can at the end scale our manufacturing lines here quite fast. Yeah? And this is purely possible due to that experience which we have gained in the last couple of years.
But is it some sort of agile work, or is it, let's say, rather corporate-like already, that you, I don't know, have certain processes that you're following, or is it's still a somehow agile one?
I mean, we have for sure internal development processes. We also have product development processes. We are IETF certificated, so in that case, it is a must-have. But at the end, I would say, before I joined Skeleton, I worked at a really huge corporate, and there was the product development cycle roughly 15 years old, and I would say there were some of the 1,500 work packages in which were maybe not state of the art. And I think this is something what you can avoid in these young companies. That means all the different processes which we have established have always just one target. They do not, let's say the target is not to just fulfill any certification requirement. At the end, we use and set up the processes in a way that we can use them for our company, for our growth, and at the end in the most efficient way.
Sounds good. Kees, what is required to scale flow batteries in general, let's say?
Give you some background on our approach. In flow batteries, you have different chemistries. The most common one is vanadium based, and that's the one we're using, but there are new ones evolving, organic, but also other metals. So we looked into the different segments, and in each segment we're talking with the market leader. One of them is, for instance, a top 100 US company with a new electrolyte, and we're partnering with them very close to make that specific stack which fits their system, whilst staying as standard as possible, because that's an important remark. And we have certain machines, we have to be able to build them on our machines. And most often it's only changing in the membrane, so that's not that much, but that's important. So standardize, so your costs stay low, and partner with the right partners to be able to scale, because they need gigawatts of stacks. So that's our approach. So it's partnering, indeed.
Mm-hmm.
Yeah.
Interesting. I have two more questions, and then I give room to the audience to also ask questions. Starting with Peter, I see that you are quite interested to take a question, but I have one left for Frank, which is basically rather two questions than one. But let's answer it quickly. First is, how important do you see it to have, let's say, strong shareholders as you won in your last in the Series C? So one question. The second is, if you are successful, and no doubt that this will happen, that would be a tremendous change or breakthrough in wafer production. Do you see some let's say framing elements also, some forces that are maybe, I don't know, hindering you to succeed? Is there something like, I don't know?
Well, let's start with the first one. I think it's important to have strong investors, because they can help you. They have a network, they have the connections you don't have, they can help you to open doors, and they bring support when needed. So strong investors are very helpful and important for growing a company. Then the second question, what is needed? What kind of framework is needed? And I think being a German, being a European company, well, we are suffering, or have been suffering in the past, from the non-existence of a framework for solar. Solar has not been strategic in Europe. Yeah? Now, it changed because of the Ukrainian war, a little bit faster than we hoped, which is good. But still, there is a commitment to build solar energy production in Europe. And this is strategic. What I'm missing still is the strategic intent from the European Commission and the member states to reshore manufacturing of solar PV in Europe. as of today, 98% of the wafers come from China, yeah? Produced mainly from coal-powered energy, yeah? And in regions where some people have concerns about the human rights. Yeah? So we have to think about if we want to have the cheapest solar modules from China, or if we want to have an energy transition and maintain independence in Europe. And this requires the real shoring of the manufacturing chain for photovoltaic modules. And there are statements that we do everything it takes to do it, yeah? But we have to act quickly. We have to walk the talk, and we have to transfer these statements into legislations very quickly. We need, you guys help to create a European battery alliance. What we need is a European solar alliance to reshore manufacturing in Europe.
We're working on this. Okay, thanks. Till, one last question before we give it the room to the audience to ask. Well, this is no doubt that software innovations has been favorized by investors in the past. Only 3 out of 20 unicorns from Europe are hardware ones. So, do you see in the future a change in this that hardware ones get a larger stake in investor interest?
Yeah, I mean, first of all, I would certainly agree. I mean, maybe even to some extent you could say venture capital had become a bit lazy. There were so many software startups which had very low operating costs. It's basically people, a bit of server capacity and so on. And so the temptation to just invest in small amounts in software startups rather than in making bigger bets was certainly there, and it's certainly not helped in the industry as well. I think from our perspective, in the energy system, it's inevitable that there are always some hardware components coming along. I mean, we're currently looking at an energy as a service company which has a very nice software to manage microgrids, but what they realized was that the clients don't just want to buy software, they want to buy a whole system. And so obviously in the next step they have to provide the hardware as well and integrate an offering that includes hardware and software. And that is okay for us. And I think we need more venture capitalists that think creatively about ways to integrate hardware also into the overall solutions that startups can provide. And I think actually what is nice and what we see now is that there are more and more options to finance also assets and hardware alongside software solutions. So you have, I mean, the biggest example I think in Germany is NPAL, which is providing effectively solar roofs as a service, and they obviously have now a huge finance facility, but it can go in much smaller increments, that you provide a mix of solutions that is financed by financial institutions. And I think that will certainly play a bigger part, because especially now that inflation is starting to become a topic again, real assets, which is what hardware is ultimately all about, suddenly gains much more value as well.
Yeah, I think. So, if there are some questions from the audience, starting with Peter maybe.
I'll also be handing the mic around to people who have questions. Yes, I do have one. I would like to, what we've been hearing, thank you very much, it has been a very detailed and I think up-to-date discussion on what the challenges are of these scale-ups, of bringing these technologies to market. Now we have other companies in the audience, of course, but we also have people from the policy scope, people working on the regulation, people working on the ecosystems maybe, the market design that might help you. So my first question would be, if I may, open to anyone, what would help you when you think of Europe? Because there's a lot to be scaled up in future if we want to get the energy transition done. What would help you most at the moment, besides finding the right investor, of course, besides the team up with maybe large corporates, which we've heard. But if you think of the regulative side, the market design, any ideas on this? Till?
Yeah, maybe I can start. The mic, yeah, is working. To be honest, I don't think it needs some sort of big regulatory shift necessarily. to be honest, what we see most frequently is really the nitty-gritty of bureaucracy and permitting and planning that often significantly delays even small projects. I talked about this sort of microgrid operations. I mean, the amount of paperwork you need to put something up on your own roof as a corporate, to register it, to operate it in with the different markets, it's mind-boggling. And I think certainly here, for startups that have cash runways of maybe 12, 18 months, they need to show some sort of progress over that period. That can already kill a good idea, because simply by the time that your money runs out, you might just have received a permit, but then don't have an investor to show something for real as a follow-on to raise further funds.
So deregulation. Kees?
I tend to disagree. We had this discussion this morning, and I think that the issue I see is that the need, but also the potential, also the need of storage is not seen yet. There's no policy on storage. There's a policy maybe, and that's your good news. On solar, a little bit. On wind, a little bit, but there's nothing on storage. There's no policy. There's no target. There's nothing. Yeah? And we're living in an old situation where there was no storage, and we need to go to a new situation and fast. There's no business model for long-term storage because we're working in the old ecosystem.
Thank you, Kees. I've seen heads nodding in the audience, and in this case, I would also agree that it's neglected relatively. Shall we?
In photovoltaics, we need an active industrialization politic in Europe.
Yeah.
If we want to have, and this is where we're working on with the ESI as well. We try to convince the EU Commission. We also talking to the government in Germany. Was a concrete action plan that, from our point of view, would need to be taken to bring back an PV industry to Europe.
Yeah. Maybe I can add, it's not that much to be implemented. So I think we have innovation in Europe. I would almost say we are world leader in creating innovative technologies. Yeah, we are far behind other regions in the world to commercialize the IP we have created with our taxpayers' money. It's easy to get 2.5 million grand for developing a technology, but if you want to scale up, if you want to survive the valley of death, yeah, then you really must love hikes in the desert. Yeah, I do personally. Yeah, I love doing it, but it's a different story. Yeah, so and what we need is a level playing field. Yeah, it's for me. I'm not talking about NexWafe, but about, let's say, solar module producers, yeah? There's a crazy situation that if you import a solar module, there's no import duties on it. If you import the glass for making a solar module in Europe and keeping part of the value creation in Europe, yeah, then you have to pay import duties on the glass, and all of a sudden you're not able to compete with the Chinese competitors anymore. And also, carbon pricing is not taken into account at all. Yeah, so you can use coal-fired power plants to make not that green solar modules in China. You can ship them all the way to Europe, yeah, and there's no carbon pricing added into it, yeah, and so I think that's not a level playing field, and we have to work on creating such, and then we will be competitive in Europe.
To suggest, I think this is knowledge you have, very specific for your industry. And there should be more interaction with startups maybe and regulators in that sense. I think that would help.
You know, and I don't want to steal the show here, but it's over to you, Fabian, again. But it would be great. We promised to finish on time because some of you have to get trains and so. I think, how about allowing a question from the audience, but then Kees has just raised it, and Frank as well, your key wishes, because we would like, I'm mentioning this in every panel, I know, but we want key takeaways from this. We want to communicate them. You know, there'll be the recordings, but there'll also be, we want to summarize this. So it would be great if we had a quick final round of key takeaways, but I'd first serve as the mic boy here and ask for questions to these innovators. Is there anyone who would like to raise a question?
We've answered all the questions already.
It's hot in here, I understand. Yeah. We wouldn't expect tropical weather in Germany here, in Remscheid at least.
Linus, is there something that you would like to have from the regulator or from government that would help you to scale even faster?
I mean, the most important things were already said. At the end, all these, the funding, what you can get is at the end very good. Yeah, I think we all cannot complain. But at the end, it's all about the speed. Yeah, so we are talking in some cases on the European level about IBC-Is. Here we are talking about an application phase and a release phase of up to 2 years, which is a tremendous amount of time. Yeah, so this must be something what must be optimized. It must, let's say, other companies are starting to develop a complete new product and they industrialize it within 18 months. And we use that same time frame for the application and release process. So this is something what we need to, what must be improved. But at the end, I think what was actually also just said is also one extremely important thing. What I see at the moment quite positive actually in Europe, but also in Germany, that at the end we make this push to, and we give money, or let's say the government gives money as a kind of funding that the initial development can be done. But at the end, then there is this phase, we just called it Valley of Death, what comes quite soon, that the business has to stand on own feet. And I would say this is actually not so bad, because where is the gap, let's say, until which point of time you should fund the business, and until when not there is a, let's say, high risk, like it is done in other continents, that the complete business just work actually because of extreme high investments and fundings, and there's never ever the pressure to be independent at the end. So I think this here I would say like also like the battery regulation which we have now on the European level, these are the right frameworks. These frameworks forces some of the businesses to be in Europe, to have some recycling to have here some recycling ratios in the products, and all of that at the end forces the different companies to rethink some of the technologies, to rethink some of the businesses, but at the end they have to do it alone. And I think out of that they are independent, and this creates then this kind of extreme sustainability what we have in the middle of Europe.
So you think that Skeleton would not have scaled faster being a US company?
This is a very good question. Maybe yes, because maybe we would have taken a bit more technical risks on our shoulders, could be, but maybe we would have failed then as well, so could be, but maybe I wouldn't sit here if we would have done it in that way.
All right, thanks.
Kees had a question. I was just told to go away from that.
Just a small remark on regulation. I think the battery passport mentioned is excellent. The only thing is they forgot about the flow battery. So now we're having a regulation for batteries and we're not in. Imagine buying a fridge with 3 stars, 5 stars in efficiency and one doesn't have one. That's the flow battery. And that's a regulation in Europe. And we talked with them and they agree that it's not right, but it's a lot of work. So in 5 years' time they will maybe put us in. That's the regulation.
Thank you. Fabian.
That's true.
Let's be more optimistic. Let's not end like this. I'm still very optimistic, and it's not done yet, and it's not a done deal. We're working on it, so I'm still confident we'll get there.
So Peter wants to have his takeaway. So if we may, each of us wrap up a bit. What is for each of us the key of our discussion? How to scale, how to scale fastly, energy innovation. In order to really make an energy transition happen. So, Kees, what is your key takeaway?
There are a few, obviously. I think it's very important to get to a first viable product and have it in the market and show it, because that's important for investors, that's important for regulators, that's the belief. Secondly, there's not just one technology. We are all different, we're not competing at all. If you talk about storage, the market is going to be tremendous. And what I expect from regulators is that they enable this taking up of all these different technologies in the storage market, if I talk about storage, with an open view of enabling it and not regulating it, enabling it.
Very good. Frank.
Well, now it's difficult to add something because, well, I fully agree with what Kees said. And so I can repeat myself, so saying what we need is in solar is a framework which makes manufacturing in Europe strategic, which makes that clear to everybody involved in the administration that we need speed. We need it now. We don't need it in 3 years' time.
Okay, interesting. Two.
Yeah, I think I want to actually pick up on Kees' point earlier because it's actually a good one that regulators should really listen more to startups. I think you often we complain about speed and why is that? I mean, sometimes it's also because there's this phenomenon of regulatory capture that actually some of the incumbents are quite happy for slow-moving developments because it keeps a bit the competitors at bay. And when I look at the venture world, and I mean we look per year at over 1,000 companies. It's amazing what creativity is out there, and sometimes you only need small changes that opens up markets, and you will have a flood of startups coming in, and probably 8 out of 10 will fail, but then you might have 2 that go through, and then there is a new market, there's a new potential here. And so I think definitely startups probably also need to do more to be heard, but definitely regulators should not just listen to established industry players, but really try actively to listen to the voice of startups as well.
Linus, what is the holy grail to scale startups?
Yeah, I think I repeat now myself, but I think this is also correct. But from my perspective, protect your IP, know your customers, know the products of your customers, convince your customers that your product will make their life better and cheaper. This is maybe more important. Don't scale from lab scale to fully automatized mass production. Do one step in between. Also ask friends, partners, or whoever who have already done it. They will help, they can help. And one thing what I have learned, which is maybe also my key takeaway, even if there is a technology which might have failed in Europe, like the PV business, it's never too late to rethink about it. There are new ideas, new businesses, new concepts, and it's never too late to invest and to go into business again when it's worth it.
Yeah, thanks a lot. So yeah, I think we have a lot of concepts, a lot of things how this can happen, and this is something that we also as InnoEnergy strongly believe that hardware is something that can be scaled, that's something where also investors can jump in. And I think the first thing is you stressed it that clearly we need business cases that are flying, and this is also something that addresses the regulator. But secondly, even we have via business cases in theory, it's still a hard game to really scale hardware ventures, and this requires good teams, the right shareholders, and really, let's say, focused on growth, operational model, and last but not least, somehow cooperation in the right time with industrialization know-how. This is my strong opinion, and this can be leveraged by bringing together the entire value chain, to make also breakthroughs happen that are, let's say, breaking off value chains that has been in place for decades.
That was your final word. Thank you so much, everyone. I'm taking over my co-moderator role to close the panel. Thank everyone for coming out. It's been a long journey, but you're really rounding this off closely before our final panel where the moderator already arrived. Thank you for taking the time. We'll breathe some fresh air into this place. We'll take a 5 to 10 minute break. We'll let you know when it starts again. We'll summarize your findings. We'll share them. We're happy if you contribute, and we wish you all best for continuing scaling your companies. So thank you very much, and let's meet again for the final road to Sharm el-Sheikh in around 10 minutes. Thank you.